All right, we're back. We just talked about algorithms, and now we're going to talk about expressing algorithms as pseudocode. So using pseudocode. Says, recall our earlier problem. This was the problem. Given a non-empty array of numbers, find the largest number. And so what we do is we start talking about, this is the name of our algorithm, or when we express an algorithm as pseudocode, we might call it a function, right? We might call it a function or a procedure, depending on the terminology we use. Code fragment would work as well, but there's the name, find max. The input is A, the list of numbers A of length n greater than 0. And our output is going to be the value of the largest number in A. And these three things here together are called the definition or signature. That's a RESTAL term. It's not standard in the world of computer science, but I'm going to call that the definition of the function. And these three lines kind of explain what the pseudocode is going to do. Nothing's actually run. This is kind of just like the setup. So each line of pseudocode should be a simple task or a function call. And so when we start writing our pseudocode, it's not big things we're doing. It's small things. Simple task. Okay, great. So what's a simple task? A simple task are the following. Arithmetic operations, adding and subtracting. There's determining the ceiling or a floor of a number. That's the idea of rounding up or rounding down. Comparisons, so all the Boolean comparisons are simple tasks. Boolean operations, putting them together and or not, so jamming together comparisons, those are all simple tasks. Storing a value, so assignment is a simple task. Looking up a stored value, so finding something from memory, that's a simple task. Moving to another point in the algorithm, so a loop or a branch, an if statement, looping back to the beginning of a loop, that is a simple task. Starting another algorithm, that was the idea here. Each line of pseudocode should be a simple task or a function call. So starting another algorithm is a simple task. Returning a value, so that's at the end. We return whatever our output is. That's a simple task. Notes. A combination of simple tasks is a simple task. So any number of these things jammed together is also considered a simple task. But if the number of steps is unclear, like for instance, if it's dependent on the length of the input, it is not simple. And that's not allowed in pseudocode. And we'll talk about that soon. But if it's unclear how many steps belongs on that one pseudocode line, it's no good. It's not simple. Okay, so let's tackle this problem and write some pseudocode. So we've got our header, or our signature, our function signature, same as we had before. Here's attempt 1. And notice I've got some notes about pseudocode on the right-hand side that we'll talk about. Attempt 1. So we've got line numbers in our pseudocode, and the line numbers are optional. We don't have to put them there. The temp is a variable. And notice we didn't declare, we didn't say what type of number it was, but we're just using it. Notice the blue words here, we reserve some words for clear purposes. So max, we know what max means. We're going to find the maximum of those two. It's like a comparison. This item business we'll talk about in a second, but there are, let's see if I can get there. Yes. Some obvious built-in functions. So item AI returns item I of an array list I. So this is like a little built-in function. We don't have to explain it. We can just use it. And it will return the value in a list or in an array. Notice that we can make an empty list. We can check and see if the list is empty. That's a Boolean, right? That's a Boolean function. And we can look up the length of an array as well. And so here's a little trying to find the highest value of our array. So notice temp finds the maximum of the first two items in the array, puts it in temp, and temp2 finds the maximum of temp3 and item3 and returns temp. So certainly this algorithm will return the highest number in array A, but it's not scalable. This only works for arrays that have 3 items. That's it. It won't work if array A has more than that. So that's a problem. This is not scalable. Attempt 2. So return the maximum of item A1, all the way up to item AN. This was a simple task up here. Is this a simple task? Well, it's not, because we don't know how many comparisons this is. It should be line 4 is not simple there. Line 4 is not simple. Because this is dependent on the input. We don't know how long array A is. It's not simple. So this is no good. That one was no good. Let's try again. Attempt 3. And this is hopefully what you were thinking. So we're putting in temp, the first item in the array, and then we can loop. And this looks code-ish, but it reads okay for some counter from 1 to n, and we know that n was the length of our array because it was part of the input, 1 to n. Notice we could have, instead of n here, we could have used the length of A, or even assigned n to be the length of A before that. That would have worked as well. And then we enter our loop. And notice that when I enter a loop, I indent. We knew that from doing algorithms last year. Then it says is if item A count, where count was our for loop, our counter for our for loop is greater than temp, then we're going to assign item A count to temp. And in temp is kind of the biggest values that we've checked out so far. And notice I've indented the if structure as well. All of these are simple. You say, well, Mr. Restall, this is depending on the length of the array. Well, that's true, except for each time that that's executed, that's a simple task, right? It's only moving count up 1, it's checking a condition, that sort of thing. And then at the end of all this, we're going to return temp. That's it. What's the problem with this one? Well, there is no problem. This is a pretty good little pseudocode. Notice that the right arrow, or the left arrow rather, shows an assignment. This is, and the reason why we had this first line here, you have to make sure all variables in a comparison and on the right side of an assignment have a value. This is similar to when we program. If you can't find that right arrow, or the left arrow rather, what we can do is we can use like a less than sign and a dash, which doesn't really look like a left arrow, but that works. I want to show you another one. Attempt 4. What we could do is we could sort our array A and return just the last item in that array. And it says if we call another function and it is not defined, we don't know what this function sort does. Probably just from the title you would know, but we would have to at least give the definition. So here's the definition of the sort. Notice that the details are actually left out, but sort A, the input is a list of numbers A of length n greater than 0, and the output is a list of numbers A sorted from lowest to highest. So we don't know the details, but this function call makes this line a simple task. And notice, once I've sorted it and put it into this new list, all I'd have to do is pick off the last value. And this is an algorithm that is simple. It's scalable because it depends on n. So what's the problem? Well, this is fine pseudocode, but it may not be a great algorithm because sort A may be slow. There's no reason to sort this array to find the largest value. Right? We don't need to sort the whole array. This will be slow. And remember, one of the aspects of a good algorithm is for it to be fast. This is correct, but perhaps not fast. Okay, I think that's it. Yep, it's time for homework. Hopefully that made sense. Posted is a bunch of other pseudocode conventions that kind of will look like the pseudocode that I've written. And if you're worried whether yours looks right, well, ask, okay? And that's all I have to say about that.